A 2D case of overland flow is simulated in this example. The geometry is displayed in the figure, in which a sloping V-shaped land surface, or overland plane, discharges into a channel. The overland plane has a slope of 0.05 and the channel has a slope of 0.02 and a width of 20 meter. The depth of the channel varies linearly from 1 meter at the upstream end to 20 meter at the downstream end. A simulation has been carried out under a constant rainfall intensity of 10.8 millimeter per hour and zero infiltration with a rainfall duration of 1.5 hours. The precipitation was assumed to not affect the channel. The Manning's roughness coefficient was 0.015 for the overland and 0.15 for the channel. Calculated discharge at the channel exit was used to compare the numerical results from other models. The IGW modules used in this example include precipitation, 2D overland flow, 1D channel flow, and surface infiltration. Start up IGW from the desktop and close the Google Map window. In the IGW main menu, define a workspace of 1,640 meters by 1,000 meters. In the Display Options menu, remove both the horizontal and vertical scale bars, then click the Create Polygon icon to create the domain polygon using the Input Vertex Coordinates input box at the bottom of the workspace. Follow the same steps to create a polygon for the channel area. Open Attributes Explorer to edit the properties for each of these polygons. For the domain polygon, check Top Elevation in the Elevations tab, select Raster, and import the Digital Elevation Model, or DEM, from a raster file. Click on Overland Flow to bring up the Surface Water Overland Flow Options window and check the Overland Flow box. In the Climate tab, select From Rain Gauges and click Edit/Load from File to open a rainfall station time series window. Click on the Add button to manually add a new station and edit the rainfall time series. Make sure to use the correct units for rainfall intensity. In the Land Use and Cover tab, select Constant and input 0.015 for the Manning coefficient and 0 for all other input boxes. In the Soil Type tab, uncheck the Soil Type box and leave the parameters in all other tabs at their default settings. For the Channel polygon, click on Overland Flow to bring up the Surface Water Overland Flow Options window and check the Overland Flow box. In the Climate tab, select From Rain Gauges and click Edit/Load from File and add a new station with 0 rainfall intensity throughout the entire time series. In the Land Use and Cover tab, select Constant and input 0.015 for the Manning coefficient and uncheck the Soil Type box in the Soil Type tab. Click on the Create Polylines icon and double-click the Input Vertex Coordinates input box at the bottom of the workspace to create a channel link from a channel configuration file. Edit this link by selecting the link and bringing up the Attributes Explorer window, then select Two-Way in the Head-Dependent Flex box, and then open the Polyline Attributes table. Change all cells in the river stage column from their default values to 20 meters. Linearly interpolate values in the river bottom column from 20 meters at the first node to 0 meter at the last node. Change all cells in the roughness column from their default value to 0.15. Change all cells in the channel width column from their default value to 20 meters. Linearly interpolate values in the channel depth column from 0.68 meters at the first node to 20 meters at the last node. Change the node type of the last node from 1 to 999. A rectangular cross-section is used in this example, and there is no need to import the cross-section data from a cross-section file. And then Surface Water Channel to bring up the Surface Water More Options window. Then turn on the Channel Flow module. Click on the clock icon to set up a transient model. The global time step used in this example is 30 seconds, which means the channel flow time step is 0.5 seconds. The simulation length is 1 day. Discretize the model with a grid size of 20 meters. Customize the displayed layers. A surface water monitoring well will be automatically created at the last node of the channel. Open the monitoring well and select the parameter to show. Then customize its location and size. Run the model. IGW allows the user to stop or pause the model at any time to customize the display of the model results and chart, or to dynamically draw a profile. Pause the model and add observations or other existing data to the monitoring well window for comparison. Again, run the model. We can see that the IGW results match well with observations.